All right, lads, back at it again. It's June 16th, uh, almost 2 p.m. This is the one that we did yesterday, sliding window maximum. Um, yeah, so you're going through the thing, and then, so what it was using a queue, right, of ints. And then what I wanted to do was, if then I'll just push it in, right? I also have a vector thing here. I don't really remember this, if I'm being honest. I used max heat to solve this. That one I remember, but the actual sliding window one, I don't really remember how to do. This was the max heat one, right? Yeah, but that's not the one that I am going for. This is the dynamic one. And then it was this while the queue is not empty. Okay. And then while the queue is not empty and dq dot back. No, and nums dq dot back is smaller than nums I, right? Then what you want to do is dq dot pop back or front. You pop the back. Let's use dq. Is that what it is? And then once it's bigger, then I'll push back I, right? Then once I have that, then the Q will be normal. Then what was it? Hmm. And then if Q is bigger, if L is bigger than Q dot front, Q dot pop front. I don't really understand this. So I'm gonna look at this one. I think it was this one. If IDX is bigger than K, number I minus k is equals to q dot front. And the number I minus k then q dot pop front, right? If uh, I plus 1 if I is bigger than k, bigger or equals to k minus 1, then what do I do? Like that? Fuck. Bum, 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 bum. I don't really understand this, if I'm being honest. So while Q is not empty and Q back is smaller than nums, and I'll get rid of all the numbers, and then I'll push in the biggest one, right? And then if I is bigger than K and nums I minus K, which should be the leftmost element, is equals to Q front, then I'll pop it. And if I is bigger than equals to K minus 1, so it's the right, which will be after the first two, right? I is bigger equals to K. The thing is, I don't, what the fuck? Like, this is so fast. All right, so this is nums, right? And then this is result. And then this will be Q. Well, Q is not empty, so Q is empty now. So I'll push in one. And then if K is bigger than I is bigger than K, which it's not, so I'll skip. And then if I is bigger than K plus one, so I'll skip. And then it'll be next, which is 3. Okay, and then it is not equal. And Q back is smaller than nums I, which is 3. So I'll pop it. And then I'll push 3 in because it's empty now. And then I is smaller. Therefore, I go to the next one. And then this will be -1, right? And I is big or equals to 3. Nope, it's not. But I is bigger or equals to K minus 1. So I will push 3 into it. The next one would be -3, right? It's still descending. And now it's bigger than equals to K because I is equals to 3 now. And nums I minus K, which is 3 minus 3, which is 0. Num 0 equals to front. Then I'll pop the front. So this fucks off. And then I'll pop -1. What's num 0? So with 3. And then the next one will be 5. So I'll empty it all. And then it will be 5. I will not pop it. So it's just 5. 3. I'll put in 5. And then 6. And then I'll pop it all, and then I'll put 6. This will be 6. And then I'll pop this in 7. 삼삼 but the popping part, um, oh my God, this is so distracting. 我係咁撩耳仔，真係超級 distracting 咯，baby。哦哦，I see, I see what it's doing. Okay, now I get it. Okay, now I actually get it. Okay. Okay, cool, 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 cool. Now that I've worked it out in my head, it makes a lot more sense. What are you doing? What are you doing? Beautiful. Beautiful. Okay. Oh, dang. Baby girl. Baby cheese. Okay, this one I've done. Minimum stack. Okay, let's try and implement this. Oh, is it not on lead? Not on lead code? Evaluate reverse. This one I feel like I've done. Yeah, this one I've definitely done. Generate parentheses. You are given an integer n. Return all well-formed parentheses strings that you can generate with n pairs of parentheses. Huh. What is going on? Don't really know how to do this. Okay, let's try and do this. Daily temperatures. Maybe I've done this before, actually. Daily temp. Yeah, I have. Mm, mm, mm. Brute force would be n squared, right? Um, then the next optimization would be a some sort of stack, I feel like. You get a warmer temperature. Wow. Still like a very bad leetcode, to be honest. Damn, it's crazy. We remember when all of them occur next.我唔記得咗咁做，屌。 Okay. Stack in result. I don't want to be doing lead code, to be honest. Ah! 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 Oh. Ai, mày我做一題未做過哦，呢個 OK。Seems like this one I haven't done yet. I don't think I've done this before. Car fleet. Yep, I have not done this before. There are n cars at given miles away from the starting mile zero, traveling to reach the mile target. You are given two integer arrays, position and speed, both of length n, where position I is the starting mile of the ith car and speed I is the speed of the ith car in miles per hour. A car cannot pass another car, but it can catch up and then travel next to it at the speed of the slower car. Okay, a car fleet is a car or cars driving next to each other. The speed of the car fleet is the minimum speed of any car in the fleet. If a car catches up to a car fleet at the mile target, it will still be considered as part of the car fleet. Okay. Return the number of car fleets that will arrive at the destination. Okay. I see. Okay, so I'm thinking position and speed. And for oh fuck. Then for any given where is the target? How do I even attack this question? Give me a hint. Oh, there's no hint. Jesus. Okay. Well, I need a neat code hint. First, draw a picture of all the points which represent the positions and respective speed of the cars. It is appropriate to represent the positions and speed of each car as an array, where each cell corresponds to a car. It is also logical to sort this array based on the positions in descending order. Wait, first draw a picture of all the points which represent the positions. Mhm. The time required by each car will be What exactly? Ugh. Moment.
Hey everyone, welcome back and let's write some more neat code today. So today let's solve the problem car fleet. I think a lot of people don't end up solving this problem, but I think it's a very good problem and an interesting problem to solve. So we're given n cars that are traveling along the same road. It has one car that's eventually going to catch up. So we'll assume a heat car at the destination to do arrive at the actually arrive at the destination, which in this case, let's take a look at our own example. So here you can see I'm basically combining the two arrays that they give us. I know they give us a separate array for position and speed, but I'm just going to combine it into an array of pairs. So
What the fuck?
time on one speed mean, it means that the slope is going to be 3, right? So every unit of time that passes, second, it'll be a kind of bad drawing here. And then at time 3, it'll be at position 12. So basically, just that going on to kind of what we can tell us. That tells us that they are going to become a car fleet. This orange one and the blue one, right? Right? Because once they do intersect past the blue one slows down, which is about over here, I think, right? So that must mean closer at the drawing, we see that the orange one intersected with the green one before it intersects with the blue one. So actually, when the orange one intersects here, it's actually going to be traveling at the same rate as the green one. And you can
Mhm.
continue with this drawing if it kind of gives you a good intuition of the problem. I just wanted to kind of show you like where I'm coming from with this problem and that I'm not just immediately jumping to the solution. But knowing kind of this idea, we can kind of get into the solution to this problem. And we can actually do it in linear time. So now you can see that I've drawn the cars and their positions in sorted order. And that makes sense, right? Wouldn't we want to go through the cars in sorted order? Because of course we know that they can't, like the relative order of the cars is never going to change. So it makes sense to go through them in sorted order. Now, for any two given cars, such as these two, how do we know if they're going to intersect or, they're going to collide and become a single car fleet before they reach the destination position? Well, basically by the drawing I showed you earlier, if these two intersect each other, right? So what we could do is actually calculate the intersection point of these two if we really wanted to. But there's a slightly easier way. We can just calculate what time is this car going to reach the destination and what time is this car going to reach the destination. If this car reaches the destination before or at the same time as this one, that must mean that they became a car fleet, right? They became a car fleet somewhere in the middle, somewhere in here. So
Okay, I think I kind of understand maybe. So I just need a vector that is time for in I equals to 0. I is smaller than speed dot size plus I. 지금 concerned à 이거야. 어? 어? Boom. Okay, now I have the time taken for each car for all this. Um, if the time taken for I, while the stack is not empty, and the and if I is not zero, because if I is zero, then I'll just push it, right? Um, there could be only one car. And um and the time of I smaller than if that one is smaller than the previous one. No, if it's bigger than the previous one, right? It takes longer. That means if the time I is bigger than the top of the stack, that means I'll pop the top of the stack and I will push time I in there. Else, I will just push it and then return that. Could that be right? No? Fuck. Um, I'll push the first one in there first. And if the second one is slower than the first, That means at some point it will become a fleet. So I'll pop the res and I'll push the second time in there. Then the next one, if it is quicker, should be this maybe? No? Res dot clear. It should be clear, right? Empty. Because if I find a car slower than the previous ones, then all of the cars before will become a fleet with that one single slow car, right? So I should empty the whole stack instead, right? Isn't there a way to just clear the stack? The fuck? Pop everything? Is that it? No. What if it is slower? Then I'll push it. Everything does push I. right? Oh my God, no way. I actually got it, maybe. Fuck! What's the problem here? Okay, so this has to round up. How to round up division? Hmm, because right now this floor divides it, which is not what I want. We'll make it quicker than it seems. Um, like that. Because right now 10 minus 6 equals to 4. 4 divided by 3 is 1 point something, but it will become 1. But if I do 10 minus 6, which is 4 plus 0.5, which is 4.5 divided by 3, which will be 1. Hmm. If this is not equals 0, then right, should work. It should make this pass as well. Hmm. Right now it should be 10 minus 6, which is 4 divided by 3 should be 1. but now I make it 2. One. Now the time taken will be 2. What is this now? So this first car takes 5. Second car takes 6. 5, 6, and 3. What? Oh, I have to sort them by position first. Fuck, I'm retarded. 操你妈. By Now it should work. If the syntax is right. It's not. Can I just do this? Locate. Then it sorts in ascending key. No? Hmm. Something is wrong here. I found na, 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 da, da, na, 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 na. Na, 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 na. Mm, 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 mm. Wait, what is wrong? Don't really understand what is wrong. Don't know what's wrong. Oh, I can just cast it? Okay. The time by the current time come là sweet là tôi cái else will cut up. Well, show me the money. Fuck! What the fuck is wrong? Get baby, baby, baby Jesus, baby Jesus. Huh? Huh? Oh, that's what I'm missing. Bro, what? 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 I'm stupid. The fuck? Oh, this is double. Is that why? And now we double as well. Is that why? Am I stupid? Am I stupid? What? Okay. I'm shoving in the pairs, and then I'm sorting the array, right? I really don't know why this is wrong. That's insanity. What is wrong with this? Wait, why is it different though? Tell me in the chat. I don't know why this is different. Okay, after this leak code, I will go do the bomb lab. Phase 4, 5, 6. Um, yeah, so we sort it by position and then you see what time it takes. Oh, that's very smart, actually. Farthest to closest? Hello. Hello, sir. Oh. Ascending order, isn't that what I need? That's why I was confused. Oh, hmm.
Since this one is moving at 1 mile per hour and this one is moving at 2 miles per hour or whatever, whatever unit of speed or something that they gave us, we can calculate what time they're going to reach the destination. We can do it pretty easily, right? We can just take the distance difference for, I'm going to do the green one first. We can take 10
That's slower than that.
minus 7, right? That's the distance that we would
Oh,
travel, 3 units of distance, and divide that by the speed, in this case, 1. So this is going to reach the destination at time equals 3. We can do the same thing for this one. So 10 minus 5 divided by 2, that's going to be 2.5. So this is going to reach the destination at time 2.5. So that must mean that they are going to collide. So we know they're going to be one car fleet. So technically we can kind of just like delete one of these, right? And just not consider it anymore. But which one of these two are we going to remove, right? Like, okay, let's say I remove one and then, I start comparing the remainder of the list that's on the left side. Well, I'll tell you right now, we're always going to keep the one that comes ahead because if these collided, they're going to end up being reduced down to the speed of the one that's ahead. Then you go left to right, and they're reaching at speed one. And one more thing, we're not going to go from left to right. We're going to go from right to left when we do this
Yeah.
operation. And the reason is pretty much the same. Because if we started at the beginning and then we were checking, okay, does this one collide with the blue one? Well, we don't even know what speed the blue one is going to be traveling throughout the whole thing. We can't just assume it's traveling at speed 2 the entire time because it could collide with somebody else and slow down. That's why
Yeah.
it's better to start from the right
Yeah,
or do
okay.
this in reverse order.
Yep.
Okay, now just to complete the example, so we know that this is going to end.
Okay, I get it. That is the problem. Okay, cool. So just to write it again, in here. So I will have a vector pair in int, called comparison, and then for int I equals to 0, I is smaller than speed size, right? I'll push, um, position I, also speed I into it. And then next, what I want to do is R begin. And the reason for that is because by default it sorts ascending, but we want to process it descending, right? We want the cars that are closest to the destination, which is the highest position at the front. So we need to do a reverse sort. So a descending sort. After that, this is what we want to do. Um, we can just go auto, uh, R and R. Right. Okay, for auto car in comparison, um, no, you want equals to is nothing. This will be a double target minus um I think this works. Fine. If the time right now is bigger than current time, then there will be one more fleet. I think that's correct. So There's something about this casting thing, I believe. It should be. Yeah, so what is this? Hmm. Sigma. Papaya. Is that cream? Oh, nice, healthy. I get it, but why do I have to cast it double here first? Aren't I already casting it? What if I do this? Would that work? That work? It would. Okay, well, that's fine. Okay, that concludes the leak code portion of today. Um, going to do the bomb lab. Peace.